Hello everyone. This is the lecture on cam and follower. Cam and follower is in your third module. Other than cam and follower, you have one more topic, that is gear and gear train, that will be taken by Rahul and sir. So we'll go in detail about cam and follower. Cam and follower is a mechanism which can be classified under higher pair. As the definition of higher pair, in a cam and follower, you have two links. One is the cam and the other is the follower, and the surface and the contact between the cam and follower is a line contact. So in a cam and follower, it consists of a cam which rotates and thereby imparting a reciprocating or oscillating motion to the follower. So in this is a diagram of cam and follower. So this is the cam and this is the follower. The cam will have a rotational motion, that is the cam rotates about the center, and the follower will undergo a reciprocatory motion due to the motion of the cam. The follower will undergo a reciprocatory motion along its axis. Also in a cam and follower, the rotational motion of the cam is converted to the reciprocatory motion of the follower. The cam is connected to the shaft, so the rotational motion of the shaft is transmitted to the cam, and then thereby the conversion of the motion takes place from rotational motion to reciprocatory motion. Now we will discuss about the classifications of cam and follower. There are different classifications based on classification of follower and classification of cam. So right now we will be discussing about the classification of follower. In this also there are various classification based on various parameters. One such parameter is a surface of contact. So based on the various surface of contact, the followers are classified into these four types. The first one is the knife edge follower, that is the contact point between the follower and the cam is a knife edge. So at this point of contact, it's a knife edge. Similarly, next is the roller follower. At the point of contact between the cam and the follower is a roller. So that is basically a surf line contact. And in the case of knife edge follower, it's a point contact. Next is the flat faced follower, where the point of contact at the cam between the cam and the follower is a flat faced surface. And then the fourth one is the spherical face follower, where the surface of the follower which is in contact with the cam is of spherical shape. So now this is the second type of classification of the follower. Here the classification is based on the path of motion of the follower. So the cam and follower arrangement is classified into two. One is known as the radial follower and the other is the offset follower. In the case of radial follower, the path of the follower will be along the center of the cam. That is the axis of the follower, or another way you can say that the axis of the follower and the axis of the cam coincides, which is known as a radial follower. In the case of an offset follower, the axis of the follower and the center of the cam is separated by a distance, and that distance is known as the offset distance. So here you can see the axis of the follower and the center of the cam is separated by a distance which is known as the offset distance. So that is why it is known as a offset follower. Now we are going to discuss about the classification of the cam. Cams are classified into two. One is known as the radial cam and the other is known as the cylindrical cam. In the case of a radial cam, the axis of the follower and the axis of the cam are perpendicular to each other. So you can understand that in the case of cam, the axis of the cam is in fact perpendicular to the plane, XY plane. So when you take the angle between the axis of the cam and the axis of the follower, it will be perpendicular. And in the case of cylindrical cam, the axis of the follower, this is the follower, axis of the follower, and the cam, this is the cam, the axis of the cam are parallel to each other. So it is known as the cylindrical cam. Now we will discuss about the cam nomenclature. These are some of the terms that are used regarding cam that will be useful in the coming classes. The first point is the cam profile. Cam profile is the surface of the cam which is in contact with the follower. You can see from this figure so this is the cam profile. Now the next point is the trace point. Trace point is the reference point on the follower for the purpose of tracing the cam profile. When you draw the cam profile, you start drawing the cam profile from the trace point. In this figure, you can see this is the trace point. Sorry. That is a trace point. Now depending upon the type of follower attached to the cam, the trace point will be different. For a knife edge follower, the tip of the knife edge will be the trace point, and like in this case, if it is a roller follower, the center of the roller will be the trace point. Next is base circle. Base circle is the smallest circle drawn from the cam center to the cam profile. In the figure, you can see This is the base circle. The center will be the center of the cam, and the radius will be from the center to the cam profile. The size of the cam is decided by the base circle radius. Now the next point is the pitch curve. The pitch curve is the curve traced by the trace point if it is assumed that the follower is rotating around the cam. In the figure you can see this is the pitch curve. So the pitch curve is created by tracing the trace point around the cam profile. When you draw the cam profile, initially you will be drawing the pitch curve, and thereafter, based on the type of follower, you will be drawing the cam profile. In the case of a knife edge follower, the pitch curve will be same as the cam profile. Next is the prime circle. It is the smallest circle drawn to the pitch curve from the center of rotation of the cam. The prime circle is similar to the base circle. Only difference is here, in the case of prime circle, the circle is drawn from the center of the cam to the pitch curve. In the figure you can see the prime circle. You can see this is the prime circle. It is wrongly indicated in this particular figure, so please try to note the change. It is from the center to the pitch curve. Next is the pressure angle. Pressure angle is the angle between the direction of motion of the follower and the normal to the pitch curve at that point. Depending upon where you are taking the pressure angle will change. That is, in this figure, it is indicated at this particular location. You can see it is the angle between the direction of follower motion and the normal of the pitch curve at that particular moment. So that is the pressure angle. Next is pitch point. Pitch point is the point on the pitch curve having the maximum pressure angle. You can see for this particular figure, this is the point where you will have the maximum pressure angle. So that point is known as the pitch point. Next is cam angle. Cam angle. This is the angle of rotation of cam for a definite displacement of follower. Cam angle will be in degrees. As you know, when the cam rotates one complete revolution, then that means it has completed a cam angle of 360 degree. Next is pitch circle. Pitch circle is the circle having its center at the center of the cam, and the radius will be from the center to the pitch point. In the figure you can see this is the pitch circle. So the center of the pitch circle will be from the center of the cam to the pitch point. Next is life or the stroke. This is related to the follower. It is defined as the maximum travel of the follower from its lowest position to the topmost position. The next is the period of dwell. It is also associated with the follower. It is the period during which the follower remains stationary during some finite rotation of the cam. Both these terms can be explained using this video. You can see this is the cam and follower mechanism. So you can see the follower is going up and down. The stroke means the distance the follower travels from the lowest position to the topmost position. That is the stroke of a follower. And period of dwell is the period during which the follower remains stationary. From this video, you can see that only when the follower touches the non-circular part of the cam, the follower will be moving. When the follower surface touches the circular part of the cam, the follower is actually stationary. So that region, that portion of follower movement is known as the dwell period. Ideally, for any particular cam and follower arrangement, the motion of the follower can be classified into 4 different stages. The first one is the forward stroke. The second stage will be the first dwell period. The third stage will be the return stroke, and the fourth stage will be the second dwell period. Next is regarding the motion of the follower. The follower can have 4 different types of motion. They are 1. Uniform motion or uniform velocity. 2. The simple harmonic motion. 3. Uniform acceleration and retardation. And 4. Cycloidal motion. As we have discussed, when you consider the motion of a follower, it can be divided into 4 stages, starting with forward stroke, then dwell period, then return stroke, and then the second dwell period. This forward stroke and return stroke can be of either of these 4 motion. Sometimes the forward stroke will be simple harmonic motion and the return stroke may be uniform acceleration retardation, and likewise. Thus we finished the introductory class on cam and follower. Now in the next class we'll be starting to discuss about how to draw the cam profile. We have seen that the follower has 4 types of motion. And depending upon the type of motion, the cam profile also differs. In the next class, we will start off by discussing about the displacement diagrams of each motion of the follower. And once you are able to know how to draw the displacement diagram for the 4 types of motion of the follower, then it will be easier for you to draw the cam profile. Now that you have completed the introductory class on cam and follower, I would request you to write a detailed note on what you have learned with neat sketches, and then you can submit that online before the final submission date. So thank you all and be safe.